The fundamental theorem of algebra day 2. This is note 6.7. We're going to do this the same process and make sure that we understand the same process. I have a third degree polynomial. Let me stop. This is in your course pack on page 604. Page 604 of your course pack. Go ahead and pause and get that out. Okay, so this is a third degree polynomial. So I should have 3 zeros. That's the fundamental theorem of algebra. Graph the polynomial, define all real zeros, list the zeros. So I'm going to pull out my calculator. I'm going to plug in x to the third power minus 3x squared plus 4. Make sure I didn't make a mistake typing. X cubed minus 3x squared plus 4. If I want to do intersection, I need to make sure that the y2 is 0. And I can go ahead and graph this. I'm going to hit zoom 6 to make sure I have a standard window. There is x cubed minus 3x plus 4. If I look at this graph, I want to notice a couple things. Remember, I'm finding my x-intercepts. So here's 1, 0 root or x-intercept. This here looks like this actually might be 2. This might actually be where the vertex, the bottom part of my x cubed is actually sitting on the x-intercept. So I might have 2 roots there, so it looks like I can see all 3 of my intercepts. So I'm going to go ahead and do intersection. So I'm going to hit second trace to get the calc function. I'm doing number 5 for intersection. My first curve is the x cubed. My second curve is the y equals 0. My guess, I'm going to get closer to this equation over here, this 0, this root, and get x negative 1, 0. So my first is negative 1, 0 as my first coordinate. Bring back up my calculator. I'm going to zoom in to double check that I am looking at a vertex here. So I'm going to go back to my window, look at my graph. My x's are between 1 and 3. So I'm going to just double check and have my x's between 1 and 3. I'm going to hit graph. Yeah, that looks like that's right on the x-intercept. So I'm going to hit zoom 6 to go back out so I get my normal window. And I'm going to go ahead and hit second trace to get the calc. I'm going to hit number 5. My first curve is the x cubed. My second curve is y equals 0. So my guess, I want to get close to this point here and hit enter. Notice it only finds negative 1, 0. Why does that work? Because I'm looking at an intersection point. This is one that I wanted to show you. This is what I wanted you to see. The computer only sees this one intersection point. Why? Because the computer is looking for a change, a difference in a negative and a positive. If my intersection point is actually a vertex, there's no difference in change to negative to positive. So the computer doesn't actually, the calculator doesn't actually see that change, that difference. So how do I find that root? Well, that's why I have another option. I hit second trace. I want to go ahead and find my 0. My left bound, I'm going to get on the left side of where I think this point is and hit enter. Get over to my right side and hit enter. Get in the middle and hit enter. And this finds my 0. Realize the calculator isn't as smart as we are. We do need to say that this is 2, 0. And we need to know that that's a double root because it's at the bottom of a vertex like that. That's a double root. So my real zeros are negative 1 and 2. Did you find all the zeros you expected by graphing? Yes. Synthetic division will also produce the same zeros. Use synthetic division to find a quadratic equation. Remember, technically speaking, I have a double root. I could write a second 2 up there. I really don't need to. But let's remember our synthetic division. This is a coordinate negative 1, 0. So let's use synthetic division. That means that's the factor x plus 1. That means in the box I still have that negative 1. My equation is x cubed, so I have 1. Negative 3x squared, so that's negative 3. There's no x term, so I put in a 0. My constant term is 4. I draw my line, and the first thing I do is I drop my first term. Negative 1 times 1 is negative 1. Negative 3 minus 1, or plus a negative 1, is negative 4. Negative 1 times a negative 4 is a positive 4. 0 plus 4 is 4. Negative 1 times 4 is negative 4. I get 0. I get my quadratic equation is 1x squared minus 4x plus 4. If I factor this out, what multiplies to be positive 4 and adds to be negative 4? Well, that's x minus 2. X minus 2. Or I can say that's x minus 2 quantity squared. Both of those are the same. Write the polynomial function in factored form. So I have f of x is equal to, my first factor was x plus 1. Then my other two factors are x minus 2 quantity squared. There's my polynomial in factored form. What were my zeros? Negative 1, 2, and 2. They were all real. I had that double root, that double 0, that double x-intercept because the vertex came down on the x-axis. Let's try example number 5. Example number 5 says, using the same steps as above, find all zeros real and or imaginary. Write the polynomial function in factored form. Do the same thing. I pull out my handy dandy little calculator. I go to y equals. I type in my, I'm going to hit clear just to be safe. Type in my function x. I'm going to hit math to get the cube, number 3. X cubed plus 2x squared minus x plus 15. Step back, make sure I didn't make a mistake. X cubed plus, it's just x squared minus x plus 15. I made that mistake. I need to make sure I get rid of that. X cubed plus x squared minus x plus 15. That looks correct. I hit enter. I'm going to hit zoom 6 to make sure I'm going from negative 10 to 10, negative 10 to 10. I see one intersection, but I don't see any more than that. Could it be that they are imaginary? Yes, but I want to double check. I'm going to try zoom 0. Zoom 0 says zoom fit. That's what my graph looks like. It looks like it is going to be imaginary. It looks like I'm just going to have that one real root. So I'm going to hit zoom 6 to have my regular standard window. By the way, what does zoom 6 do? If I go to window, zoom 6, all it does is give me an x min of negative 10, an x max of 10, an x scale of 1, and it repeats that for the y. It's a standard window. Zoom 0 gives me a zoom fit. It tries to see the entire picture as best as the calculator can do. So when I hit zoom 0, it showed me that it looks like I just have that one intersection. I don't have anything else coming down. So I'm going to go back to my zoom 6, my standard window, so I can find that one intersection point that I have there. So I'm going to go ahead and hit, remember under the y equals, the y2 is equal to 0, so I can do intersection. So second trace, number 5 is intersection. First curve is the x cubed. Second curve is the y equals 0. Guess, I'm going to come close to this point. Do I really need to? No, but I'm going to do it anyways. And my intersection is negative 3, 0. So I found the coordinate negative 3, 0. That tells me that I have a real root of positive 3. I lied. I have a real root of negative 3. That means I have a factor of x plus 3. Fantastic. What do I do at this point? Well, at this point, I need to use synthetic division to find my imaginary roots, my imaginary zeros, my imaginary x-intercepts. Those are all the same thing. So since it's x plus 3, since my 0 is negative 3, inside the box I get a negative 3. I have an x cubed, an x squared, an x, and a constant, so I don't need any zeros. The coefficient in front of the x cubed is 1. The coefficient in front of the x squared is 1. The coefficient in front of the x is negative 1. And the constant is 15. I draw my line, and I drop down my first number. Negative 3 times 1 is negative 3. 1 minus 3 or plus a negative 3 is negative 2. Negative 3 times negative 2 is 6. Let's make that a negative 6 because negative 3 times negative 2. Oh, that's a positive 6. I'm multiplying. Negative 1 plus 6 is 5. Negative 3 times 5 is negative 15. I add down, I get 0. What if I had kept that as a negative 6? I wouldn't have ended up with a 0 because negative 1 minus 6 is going to be a negative 7. Negative 3 times negative 7 is 21. 15 plus 21 is going to be this 42. I know this has to be a root. I know that my remainder has to be 0, so I would have known I had made a mistake. So this kind of worked out. I need to make sure not to make those mistakes. What is this factor? This factor is x squared minus 2x plus 5. That's one of my factors. So f of x is equal to x plus 3 times x squared minus 2x plus 5. So now I have this. I want to see if I can find factors. Is this factorable? What multiplies to be positive 5 and adds to be negative 2? Well, only thing that I know that multiplies to be positive 5 that's whole numbers is 1 and 5, and that will never add up to be a negative 2. So at this point, I have to use the quadratic equation. So I would say x is equal to negative 2 plus or minus the square root of that negative 2 squared minus 4 times a, which is 1, times c, which is 5, all over 2 times a, which is 2 times 1. I continue. Negative 2 is positive 2 plus or minus the square root of negative 2 squared is 4. 4 times 1 times 5 is 20, minus 20, all over 2 times 1, which is 2. So this is equal to 2 plus or minus the square root of 4 minus 20. Well, that's a negative 16 over 2. This is equal to 2 plus or minus. The square root of 16 is 4. The square root of negative 1 or negative 16 also gives me I or 4i. And this is all over 2. I can now break up this fraction into this part and this part. So I get 2 plus 2 over 2 plus or minus 4i over 2. Break it into two parts of my fraction. So this is 1 plus or minus 2i. That is my two other answers, are my two other answers. So what do I have? I have, as I go back up, a real 0 of negative 3. So my zeros are x is equal to negative 3. X is equal to 1 plus 2i, 1 minus 2i. Could I say that's negative 3 and 1 plus or minus 2i? Sure, I could write it either way. Those are my three roots, my three zeros. What's my factor? Well, my factored form is this. So I'm just going to copy this. Excuse me, I'm going to clone this and slide this down to say, okay, now that I have my zeros, I have my factors. Could I write something with this 1 plus 2i, 1 minus 2i as a factor? Sure, but I want something that looks nice, that looks real. So this is my final answer. I have my zeros, my roots, and I have my factored form. So I am done. That is example number 5. Let's look at examples 6 and 7. Write the equation of a polynomial function in factored form with zeros at x equals -6, x equals 3, x equals 7, and a leading coefficient of 1. What in the world does this look like? Well, I know that I'm going to have f of x is equal to, my leading coefficient is 1. My first factor is x minus 6. That's my first 0, excuse me. So that tells me that my factor is x plus 6. My next factor, my next 0 is x equals 3. So this is x opposite sign minus 3. And my last 0 root x-intercept is x equals 7. So that means my factor is x minus 7. This fills in all the criteria. I have factors where the zeros are -6, 3, and 7, and my leading coefficient is 1. That is the equation. Let's try example number 7. We're going to set it up the same way. Write the equation of the polynomial function in factored form with zeros x equals 5, x equals 2i, and x equals -2i, and a leading coefficient of 1. Do the same thing. F of x is equal to, well, x equals 5, as my 0 says that x minus 5 is my factor. X equals 2i means x minus 2i is my factor. X equals -2i means x plus 2i is my factor. Technically speaking, I have a leading coefficient of 1. Technically speaking, that's my factored form, but that's ugly. I don't want factors with i's in it. So what I'm going to do is I'm going to go ahead and I'm going to FOIL out this portion of it so that the i's disappear. So my first is going to be x squared. My outer is going to be plus 2i. My inner is going to be minus 2i. Excuse me, plus 2ix, minus 2ix, and my last is going to be minus 2i quantity squared. So if I work that out, that's x squared. My 2ix's cancel. And remember, 2 squared is 4. I squared is -1. Minus 4 times -1 is positive 4. So there is my factor. In front of that, I know that I have x minus 5. And of course, this is my function f of x. So what I do is I take each 0 and I make it into its corresponding factor. If those zeros are imaginary numbers, I want to FOIL them out. They're always in pairs. So I want to FOIL them out and find that factor that factors out into those imaginary numbers. For this one, it's x squared plus 4. Have a great evening.